Hello, class. Good morning once again. So today we'll be looking at compounds, molecules, and mixtures. What are we going to be learning today? Today, you should be able to define a compound and also state how they are being formed. Okay. We'll also be looking at some examples of compound, differentiate between ionic and covalent compounds, differentiate between mixtures and compound, and explore the types of mixtures, master separation techniques. And then we'll also be looking at writing the formula of some chemical compounds. So follow me as we go through all these objectives together. So the first thing we're going to be looking at is, what is a compound? A compound is a pure substance made from two or more elements, chemically combined in a fixed ratio. I repeat, a compound is a pure substance made from two or more elements, chemically combined in a fixed ratio. So take, for example, water is a compound, okay, containing two elements, okay, combined in a fixed ratio. So if we're looking at water, for example, water is combined, is a product of the combination of hydrogen and oxygen in the ratio of 2:1. Okay, that is 2:1. So we have two atoms of hydrogen combining with one atom of oxygen. So if you have any other ratio different from this, even from the same set of elements, that will cease from being water. Okay, so every compound must have two or more elements, and not just two or more elements, must also have what? Fixed ratio. They must be chemically combined together. These three points makes a compound what it is. Okay. To just cite an example of a compound that can also have the same set of elements but different fixed ratio. Okay. Take, for example, you have something like this, hydrogen peroxide. This is not water, because here hydrogen and oxygen is combining with the ratio 2:2. That is 1:1. Okay, that is 1:1. So this is not water, regardless of the fact that they have the same set of elements in the compound, but the proportion of which they combine in terms of ratio is not the same. So this is water, which is a compound on its own, and this is hydrogen peroxide, okay, which is another compound on its own. Okay, so that brings us to some of the features of a compound. Okay, now why do we have compounds? We have compounds because elements try to achieve stability. Okay, they try to achieve stability. They try to reach the octet structure. So here you have something like hydrogen, for example, and oxygen trying to come together. When they combine together, they form a stable compound. They can't exist on their own, but when they come together, they achieve stability. Okay, let's do that together with another example. Here, I'm going to use sodium and chlorine coming together, okay, to form a compound called sodium chloride. Now, chlorine from your periodic table has 17 electrons, okay? If we spread that, we get 2, 8, and 7, okay? Which implies that chlorine has 7 valence electrons. So it's short of 1 to achieve stability. You know, atoms achieve stability when their outer electrons achieve the octet structure, as earlier treated in our previous topic, atomic structure. If you have not seen that video, go make sure you subscribe and then go down to our YouTube videos. You will see the topic, atomic structure. You will get a better understanding of what we mean by the stability of an atom. Okay, so chlorine here needs 1 to make it 8 so that it can achieve stability. Sodium here from your periodic table has 11 electrons, because that's atomic number of 11. So if you spread 11, you have 2, 8, 1. So here, sodium have 1 as its valence electron or outer electron. Chlorine, on the other hand, had 7. So what then will happen? Sodium would transfer this 1 electron to chlorine, okay, so that chlorine becomes Cl, okay, minus 1, because it gained 1 electron from sodium. And then sodium, because it lost 1 electron, then form what we call your sodium ion, Na+. So this brings about the combination that gives you sodium chloride. Okay, that is how sodium chloride is formed. So, and that is how they achieve stability in the process. Okay, so this is peculiar with ionic compounds. Okay, for covalent compounds, what they do is they share the electron, just like in the case of water. Okay, let's quickly look into that too. For water, we have H2O. So you have hydrogen. Hydrogen has just 1 electron as its valence electron. And you have another one here, hydrogen, with another valence electron. Oxygen from your periodic table has 6 valence electrons. Okay, because the atomic number of oxygen is 8. If you spread 8, you get 2 and 6. Okay, and that should be 1, 2, 3, 4, 5, and 6. So we'll bring this compound together. We'll bring them together. You get what we call, so you know, your Venn diagram. Okay, so now you have your hydrogen bonded to oxygen. Okay, so and the hydrogen here also bonded to oxygen. So it makes oxygen complete now, having 8 outer electrons, and at the same time making hydrogen having 2 outer electrons, which give it the stability it deserves. Okay, so this is something like this. Let me make it like a Venn diagram. Okay, so with this, you see that hydrogen has 2 outer electrons, while oxygen also have 8 outer electrons, which is a duplet and the octet structure stability, this compound. Okay, so that brings us to looking at another property of a compound. Okay, the property of a compound is different from the property of the individual elements that forms it. Okay, I'm going to talk about sodium chloride also, again, in this case. Sodium is a metal, it's a soft metal. It's gray in color, can be cut with a knife and react violently with water. In fact, it catches fire when it comes in contact with water. But chlorine, on the other hand, chlorine, you know, is poisonous. It's poisonous. It's not something we can consume. Okay, so when it touches water, it forms what you call bleach. Okay, and then both of them coming together forms sodium chloride. Now, one would believe or would think that, oh, these two coming together will be very hazardous to man. But truth be told, we use sodium chloride to season our food. That is the common salt you use at home. Okay? You pour it into water, you pour it into your food, and it doesn't catch fire, unlike the elemental sodium. Okay? So one would think the properties of sodium and chlorine will be seen in sodium chloride, but the case is not so. So when elements combine to form new compounds, the compounds they form have unique properties different from those of the elements. Okay, so these are the two unique features of a compound. So we have moved on to writing, in naming compounds. We have also moved on to writing formulas. Now let's go straight to naming of a compound when you're given a formula. Take, for example, the first thing you need to do is look at these rules here towards the left side of the screen. Okay, we have for ionic compounds. Because of time, we'll just focus on the ionic compounds. Okay, the ionic compounds, the first thing you need to do is to write the symbol of the metal, okay, and then you make your non-metal, that is combined with your metal. You change the name, the suffix precisely to IDE, okay? The suffix becomes IDE. Okay, take for example, up there we have what we call sodium chloride, right? You have Na and then Cl. Okay, if you check your periodic table for this, Na is sodium. So you just write out your metal, okay, as sodium, okay, as sodium. So Na is sodium, so I'll just write sodium. That's the first thing to do. You write out the metal. That's the first element in that compound, in that formula. Okay, so, and then the next one is chlorine. So chlorine, you change chlorine to chloride instead of chlorine. Okay, so that is basically how to name a compound. So we'll continue from where we stop sometime, probably next week, where we'll conclude the lesson. So have a great day ahead, and till we meet again. Bye.